these valves. This is a view. We were to like make a slice out of the heart that only contains the valves and look down on it. This is the view we would get. Because, like I was saying, valves ensure the one-way flow, making sure the blood flows in the one direction it's supposed to be going. We have those valves, one, like I was saying, between an atria and the ventricle, and from the atria and ventricle into the great vessels that they're going to flow into. They have the flaps. The flaps, which I tried to point out from the other picture, like the ones that were attached to the strings, okay, and the ones that lead into the great vessels, they're called the little areas that look like a flap, okay? Most of the time you'll hear them referred to as a cusp, but you might also hear them termed a leaflet. These valves, okay, that you see, remember how I mentioned that they're covered in the endocardium? This one right here, let's take this one. This right here would be flowing into the pulmonary trunk from the right side, and these valves, that endocardium, would run with the interior lining of that vessel, which would be the endothelium. Does that make sense? So on the heart side, it's the endocardium. On the vessel side, it's the endothelium. Yes, no, maybe?
Can you say that again?
Okay, so this flap is the area that is in between the heart and then the vessel that it leads into. So this little flap, okay, on the heart side, that flap is covered in the endocardium. But that little flap, as it leads into the great vessel, the lining of a vessel is endothelium. So on this side, going into the vessel, it connects to endothelium. Because need to make sure for the flap that the flap can open to allow the blood to come in and close to keep it from flowing backward. All right. I have those AV valves, which I showed in the other picture. Showed the one on the right had the 3 mountains. The one on the left had the 2. Okay. Those are my AV, or my atrioventricular, because they're between an atria and a ventricle, regulating blood between atria and ventricles. Like I showed in the picture, the right had the 3, the cords that were attaching to it, to the mountains of muscle that I tried to point out. Okay, the left had the 2 mountains, and those cords are tendinous cords, like a tendon. So these are the parts that I'm talking about. These are the tendinous cords, and I refer to them as the mountains, okay? And as you look at these are termed a papillary muscle. Papillary because they have this shape of extending out.
And you said that the tricuspid has 3 of those muscular mounts.
1, 2, 3, and that looks like a little one right
That's
there.
what I was
4,
curious
yeah,
about.
and 2 over here. But they refer to it as 1, 2, 3 in first identifications.
Okay.
So these would be those tendinous cords, because tendons are pretty tough, and tendons are attached to muscle. Okay? So they're called tendinous cords, or you may see them referred to as chordae tendineae, which just means tendinous cord. All right. Their job, connect the cusp, because that's what they're attached to that papillary muscle from the floor of the ventricle. That's their job. So when we look at these valves to the great vessels, all right, we have a great vessel that leads us into our pulmonary circuit, and we have a great vessel that leads us into our systemic circle. So the valves that go into these great vessels, they're termed semi-lunar because they look like the shape of the moon. Okay? So they're termed semi-lunar. We have the one for our pulmonary circuit because that's from the right, and we've got the one from our left for our systemic going by way of the aorta. So we have pulmonary and aortic semi-lunar valves going into those great vessels. Their job, help to regulate that blood flow. Just mentioned, from the pulmonary, for the pulmonary, it comes from the right side of the heart. For the aorta, going to the systemic is our left. The valves that we have, they do not work based upon effort of muscles. They are strictly controlled by blood pressures. Now, what does that mean? If I'm going to have blood return to my heart on the right side, it returns from the upper head, neck, extremities by way of my superior vena cava, and from the heart level, from the heart height down, it returns by way of my inferior vena cava. Both of these empty into the atrium. From the atria, it's simply, all right, so let's think of it this way. As the blood returns, this valve that would be an AV valve, because it's between the atria and the ventricle, it's going to be closed. And blood coming back to the heart would start filling in. It would start emptying into the aorta. But that has a certain amount of space. Is that correct?
Yes.
As it fills, what would happen to pressure?
It would increase.
It would increase. That means once it reaches a certain pressure, this valve has to open. And it has to allow the blood from the atria to flow to the ventricle. Does that make sense? Now, since it goes from the right ventricle into my pulmonary trunk, these semilunars would be closed. But as the blood begins to fill up, I'm going to have a pressure change, and I'll have a heartbeat because this is muscular. So when that heart beats, guess what? What's going to happen to my pulmonary semilunars? They're going to open, and when that heart beats,
The right atrium closes off.
blood moves in. This opens back up because the pressure decreased. Blood went in this direction. Does that make sense? From the lungs, it comes back. Once again, it just simply fills, just simply kind of flows into my left atria. While that valve is closed, pressure will build up. It'll let the blood flow down into the ventricle. Pressure will begin to build, but I also have my heartbeat, a whole lot of muscle through here. Heart will beat. This is closed. When the heart beats, guess what? It opens and blood flows to my aorta. This is how the valves need to work. All right? This is one of the things that'll happen in something called blood pressure. Oh, everybody heard that? Yeah, okay. We're told that there are norm values for blood pressure, right? Okay. This is what it's talking about. It is talking about what is the pressure that these muscles are under to push the blood out. So, based upon the structure that we have, the flow that we get, because return is to the right side, leaving is from the left, all right? So, let's look at my circulation. You've got to know this, okay? It is very simple, all right? And let's start where they're showing it start. Like I said, okay, blood returns to the heart by way of superior vena cava, inferior vena cava, and ooh, what's that little arrow? We're going to get to that. But that is coming from my coronary circulation, the circulation of the blood to the heart muscle itself. Okay? So, blood returns to my right atria. It has to flow from the right atria to the right ventricle. From the right ventricle, it has to flow to the pulmonary circuit. So it's going to enter to move into my pulmonary trunk so that it can flow to the lungs.
Does lung blood and the rest of the body's blood ever switch, intermingle, meet somewhere?
It shouldn't.
Okay, so the blood that goes through the lungs should only ever go through the lungs for its entire lifespan?
It should be the only one that comes to the right and enters the lungs. Now, does that mean that's always the case? No, because it can mix, and that means, but the physical effects from it are noticeable, and it usually requires repair.
So, but the cells that are made to go to the lungs, it should only ever go to the lungs.
Yes. Now, the blood flow. One of the things that we're going to see as it enters into my pulmonary trunk. Remember, in my body, where my heart is, I have a left and a right lung. All right? So on this pulmonary trunk that we get, okay, even though they're kind of not represented